The oceans contain great mysteries within their depths. While many of these mysteries have been explained by scientists and analysts, there are still quite a few unexplained oceanic enigmas that intrigue us. A variety of mysterious ocean phenomena have been seen and experienced by sailors around the world. Before we get started, be sure to click the subscribe button and click the notification bell for more amazing content. Brynicles. We used to seeing icicles form on tree branches and the eaves of buildings, but how cool is it to see the formation deep beneath the ocean, creating what's known as a brine icicle or brynicle. These icy underwater tentacles are often referred to as sea stalactites because of their bizarre appearance, but their deadly nature has earned them another nickname, icicles of death. Although already known since the 1960s, brynicles are rarely observed in real time. They're usually formed when the sea ice cracks and leaks out the saline water to the open oceans. As the brine is heavier than the water around it, it sinks to the ocean floor while freezing the relatively fresh water it comes into contact with. This process lets the brynicle grow downward. In 2011, using time-lapse cameras, BBC filmmakers recorded the phenomenon in Antarctica. The formation took 12 hours, and once the brynicle reached the ocean floor, it spread along for 6 meters. As it grows, it catches various bottom-dwelling creatures around it, such as sea urchins and starfish. Luckily, brynicles are not dangerous to humans, as man seldom travels beneath the ice sheets where they form. Divers who study brynicles take precautions to avoid hypothermia or other cold water injuries. Cyclones. It wouldn't be wrong to say cyclones are the mother of all disasters. It's one of the biggest threats to life and property, even in the formative stages of their development. They include a number of different hazards that can individually cause significant impact on life and property, such as storm surge, flooding, extreme winds, tornadoes, and lightning. Combined, these hazards interact with one another and form cyclones. These rapid-moving storms draw energy from the ocean and rotate inwardly to an area of low pressure, and clouds spiral towards the eye wall surrounding the eye. Cyclones combined with intense surface winds are also considered responsible for storm surges, an elevation of the sea surface that can reach 6 meters, resulting in a huge volume of water driven ashore at high speed and intense force, causing formidable damage to property and human life. Over the past 50 years, 1,942 disasters have been attributed to cyclones, which killed 779,324 people and caused $1,407.6 billion worth of economic losses, an average of 43 deaths and $78 million worth of damage every day. Cross sea. A cross sea looks beautiful from afar but is actually very dangerous. The pattern occurs when two wave systems cross while traveling at slanting angles to each other. The waves from the older weather system continue on until they dissipate, and the ocean becomes a swirling, dangerous place for swimmers and boats. A cross sea can also sometimes produce very tall waves. Many ship accidents have been blamed on encountering cross sea conditions. Tides of Mont Saint-Michel. The Mont Saint-Michel is one of Europe's most unforgettable sights. Set in the mesmerizing bay where Normandy and Brittany merge, the island draws the eye from great distances. Each month, the tides at Mont Saint-Michel have periods where they are extreme, and a few times each year they are dangerous. On about half of the days each month, extreme high tides almost turn the mountain into an island, while extreme low tides mean you'll need to squint off into the distance to convince yourself that there really is water in the Bay of Mont Saint-Michel. It's essential that everyone visiting Mont Saint-Michel be aware of the tides and plan accordingly, particularly if and when you walk on the sand around the island. There can be a difference of 15 meters or 50 feet between low and high tide. On about a dozen days of the year, the tides can be so extreme as to be dangerous, and they can change quickly. When wet, the sand can be unstable and a person can sink into it like quicksand, drowning as the tide rushes in. Maelstrom. Whirlpools are caused by a turbulent flow of water. When moving river water is forced to twist around an object or to stream into a narrower riverbed, the water flows faster and is more likely to create an energetic swirling turbulence. In the ocean, depending on the geology of the seabed, driving currents can collide and create conflicting tidal flows. A whirlpool of extraordinary size or violence is a maelstrom. The swirling vortex is deadly. The Maelstrom of Maelstrom is located next to Norway. Positioned near the Arctic Circle, the mightiest maelstrom in the world creates the strongest tidal currents on the globe. While the Maelstrom is the strongest maelstrom, the Maelstrom is the most famous, perhaps infamous thanks to Edgar Allan Poe and Jules Verne. Referred to as simply Maelstrom, it has the dubious honour of 1,500 years' worth of descriptions about seafarers who met sea monsters and their doom in the treacherous waters. The third largest maelstrom in the world is located in the relatively narrow Strait of Corryvreckan. Extreme tidal currents surge into whirlpools swirling around and round due in part to its location between two islands off the west coast of Scotland and the pyramidal rock on the sea floor. The largest whirlpool on the Western Hemisphere is called Old Sow. This maelstrom is situated between the shores of Deer Island and Moose Island, in between New Brunswick and Maine. Rogue wave. Rogue, freak or killer waves have been part of marine folklore for centuries, but have only been accepted as a real phenomenon by scientists over the past few decades. 10-story-high near-vertical walls of frothing water, smashed portholes and flooded cabins on the upper decks, 30-metre behemoths that rise up from nowhere to throw ships about like corks, only to slip back beneath the depths moments later. Rogues, also called extreme storm waves by scientists, are those waves which are greater than twice the size of surrounding waves, are very unpredictable, and often come unexpectedly from directions other than prevailing wind and waves. Most reports of extreme storm waves say they look like walls of water. They're often steep-sided with unusually deep troughs. Since these waves are uncommon, measurements and analysis of this phenomenon is extremely rare. Exactly how and when rogue waves form is still under investigation, but there are several known causes. Analysis of satellite imagery has suggested that they occur more often than expected, lending support to historical accounts of ships being struck and sunk by enormous waves. Rogue waves have been implicated in the disappearance of numerous ships, including the SS Waratah, Australia's Titanic, which vanished en route to Cape Town in 1909, and the SS Edmund Fitzgerald, which sank in Lake Superior in 1975. Red Tide. In H.G. Wells' 1898 novel The War of the Worlds, the invading Martians bring with them a noxious red weed that suffocates the land and poisons the water. Fortunately, it dies off at the end of the novel, killed by good old British bacteria. Real life isn't so tidy. Currently, there is no force, biological or otherwise, capable of stopping the algae blooms that are attacking coastal waters around the world with frightening regularity, turning thousands of square miles into odoriferous graveyards of dead and rotting fish. Drifting throughout the ocean, invisible to the naked eye, are innumerable microscopic algae. These tiny algae are essential components to ocean life as they fuel the food web by harnessing light energy from the sun. But when supplied with excess nutrients, they can multiply uncontrollably, becoming an unwanted mass commonly called a red tide that smothers nearby ocean life. The algae linked to red tides contains a toxin that affects the nervous and digestive system of animals. Humans are also vulnerable to the toxic effects of a red tide. Wave action can release the algae's toxins into the air, causing respiratory problems among people near the shoreline, particularly those with asthma, emphysema, or other respiratory illnesses. Tornadic Waterspout. Tornadic waterspouts are whirling columns of air and mist that form most frequently during warm seasons over oceans, harbours and lakes. They're often called tornadoes over water, but not all waterspouts are true tornadoes. Tornadic waterspouts are tornadoes that form over water or move from land to water. They form under the same severe weather conditions as ordinary tornadoes. That is, they are vertical columns of rotating air that extend from cumulonimbus or severe thunderstorm clouds down to the ground. Also, like ordinary tornadoes, they have high winds, large hail, frequent lightning, and can be fairly destructive. The lower Florida Keys report more waterspout activity than any other location in the world, and Florida is considered to be the waterspout capital of the US. Bermuda Triangle. The Bermuda Triangle, also known as the Devil's Triangle, is a loosely defined region in the western part of the North Atlantic Ocean, where a number of aircraft and ships are said to have disappeared under mysterious circumstances. Reports of unexplained occurrences in the region date to the mid-19th century. Some ships were discovered completely abandoned for no apparent reason. Others transmitted no distress signals and were never seen or heard from again. Aircraft have been reported and then vanished, and rescue missions are said to have vanished when flying in the area. However, wreckage has not been found, and some of the theories advanced to explain the repeated mysteries have been fanciful. Although theories of supernatural causes of these disappearances abound, geophysical and environmental factors are most likely responsible. One hypothesis is that pilots failed to account for the agonic line, a place at which there is no need to compensate for magnetic compass variation, as they approach the Bermuda Triangle, resulting in significant navigational error and catastrophe. Meteor Tsunami. A meteor tsunami is a tidal wave that occurs not as a result of seismic activity or an earthquake like a tsunami, but rather from atmospheric conditions. Meteor tsunamis are generally smaller than tsunamis caused by earthquakes when conditions are right, such as severe thunderstorms, squalls or other storm fronts caused by unstable atmospheric pressure activity. A meteor tsunami can occur in any type of body of water. As the storm that generated the wave moves towards the shore, the wave grows larger and larger as the continental shelf becomes more shallow. Then, as the wave approaches the shore of a coast, a meteor tsunami forms. The meteor tsunami has been reported in many places around the world, including the Great Lakes, Gulf of Mexico, Atlantic Ocean coast, and the Mediterranean and Adriatic seas. Identifying one of these waves is a challenge because its characteristics are almost identical to a seismic tsunami, making it hard to predict them and warn the public of potential disaster. Tsunami. A tsunami is a series of ocean waves that send surges of water, sometimes reaching heights of over 100 feet or 30.5 meters, onto land. These walls of water can cause widespread destruction when they crash ashore. Tsunamis are giant waves caused by earthquakes or volcanic eruptions under the sea. Out in the depths of the ocean, tsunami waves do not dramatically increase in height, but as the waves travel towards the shore, they increase, building up higher and higher heights as the depth of the ocean decreases. The speed of tsunami waves depends on the ocean depth rather than the distance from the source of the wave. Tsunami waves may travel as fast as jet planes over deep waters, only slowing down when reaching shallow waters. While tsunamis are often referred to as tidal waves, this name is discouraged by oceanographers because tides have little to do with these giant waves. The Indian Ocean tsunami in 2004 killed an estimated 225,000 people in 14 countries, including India, Sri Lanka, Indonesia and Thailand. It was caused by a powerful earthquake near the island of Sumatra, which created waves up to 100 feet high that sped to coastlines around the region. Ice Tsunami. This incredible video posted to social media by the Niagara Parks Police Service shows huge chunks of ice being pushed off of the Niagara River and onto lakeshore areas, some of which are big enough to overwhelm lampposts and retaining walls. Storm chaser David Piano told CNN the ice wall was 40 feet high in spots and starting to bulldoze trees and street lamps. These ominous ice tsunamis, known as ice shove or ice push, happen when there are perfect stormy conditions including fierce winds, loose ice and strong ocean currents that are gently sloping ashore. These striking phenomena are most likely to occur in the early spring when ice just starts to weaken and break up. Historically speaking, the scientific study of these events traces back to 1822. These piles of ice can get immense. In 2001, ice shoves on the coast of Alaska's sea reached up to 16 feet tall. Ice tsunamis are rare, but in some cases, they can be life-threatening. In 2013, waves of ice shards from a Minnesota lake destroyed people's homes. Mysterious circular holes. During research at Monterey Bay Aquarium Research Institute, officials found a vast area in the ocean bed extending up to about 1,300 square kilometers or 502 square miles. The area contains approximately 5,200 pockmarks or pits. On average, dimensions of these pits are up to 175 meters or 574 feet in diameter and 5 meters or 16 feet deep. During detailed studies, it was observed that on the seabed a large number of small holes or micro-depressions were scattered around the main holes or pockmarks. Length and depth of these micro-depressions or holes measured generally 11 meters or 36 feet and 1 meter or 3 feet respectively. The total number of these holes is considered to be around 15,000. Astonishingly, these all have undisputed circular designs and nobody on the Earth has an idea what actually led to the formation of these holes. One of the most interesting aspects of these holes is the availability of precise information about their age. As per carbon profiling, these holes were formed about 400,000 years ago. By implication, we can simply say that these holes existed even 100,000 years before scientists think that Homo sapiens started to inhabit the Earth. Consistency of these pits is much more important. According to the researchers, there has occurred no change in the structure of these pockmarks for at least 50,000 years. This means that these holes appeared on the shore of California even before any human appeared on the American continent. The history of the inhabitants in these parts can be traced back to approximately 13,000 years. Resultant to the human population, these pits on the seabed are filled with the debris of anthropogenic origins. According to the estimates, 1/3 of the whole debris consists of plastic trash bags and 18.9 litres or 5-gallon plastic buckets, whereas a fifth portion of whole comprises materials of natural origin like cobalt stones and whales' calves. Some scientists believe that creation of these unprecedented weird holes might be attributed to the release of methane gas. Methane can mix with the water and bubble up, leaving behind these depressions, but it cannot be substantiated with scientific proof, as analysis of water chemistry has completely negated the presence of methane traces. So we're all still without any clue and need to find an answer in some other domain. Therefore, some of the researchers attribute this phenomenon to the ocean currents, and another group associate it with the intense activities of the animals in the sea. Their assertions are based on the hypothesis that initially these pits were of very small size, however continuous activities of sea animals over the hundreds of thousands of years gradually increased the dimensions of the pockmarks. So far, both hypotheses lack validation. Riptide. Rip currents are powerful narrow channels of fast-moving water that are prevalent along the east, Gulf and west coasts of the US, as well as along the shores of the Great Lakes. Moving at speeds of up to 8 feet per second, rip currents can move faster than an Olympic swimmer. Panicked swimmers often try to counter a rip current by swimming straight back to the shore, putting themselves at risk of drowning because of fatigue. Lifeguards rescue tens of thousands of people from rip currents in the US every year, but it is estimated that 100 people are killed by rip currents annually. If caught in a rip current, don't fight it. Swim parallel to the shore and swim back to land at an angle. While the terms are often confused, rip currents are different from rip tides. A rip tide is a specific type of current associated with the swift movement of tidal water through inlets and the mouths of estuaries, embayments and harbours. Thank you so much for watching, and if you enjoyed the video, please let me know by clicking the like button. Do share, write a comment, and don't forget to subscribe so you can catch up my next video.